have any other questions on this page that we want to see you go over, have questions about? Now would be the time to ask if you have questions. Go on to the next page. I want you guys to try and figure out this rule as well. I'm going to start by expanding, but we're trying to figure out how could you do this without expanding. So if I had x to the third to the fourth, that would be x to the third 4 times. And as we just figured out our multiplying rule, I could add up all of these.
What?
I could have also expanded each x to the third, but since we already know that rule, we're not going to keep doing that part. So x to the third to the fourth will give us x to the 12th. Let's do another and see if we have figured out the rules. X to the fourth to the negative 7 would be x to the negative 4 7 times.
That's A.
Same thing.
A to the negative 4 7 times, yes. Whatever I just said, you know what I meant. 1, 2, 3, 4, 5. And then we have to change each one to 1 over a to the 4th. If I were to combine all of those, since we know that we're multiplying each thing, we could add up all the exponents, 4 plus 4 plus 4 plus 4 plus 4 plus 4 plus 4, which would give us
Wait, we're adding 4 plus 4.
adding up all the 4s. Anyone notice a pattern so far?
You expand it and then you add the extra.
So we're trying to not expand it at all.
So you're like raising the exponent to a power?
That is what it says, but what is the rule? You have a pass. How could I look at this and get this?
Multiply. Oh, you're just.
Multiply, yes.
I thought I was going to say that.
It's not a race. You could still say it.
Multiply.
There we go.
I said it.
So when raising an exponent to another power, we multiply the exponents. When you multiply like bases, you add the exponents. When you raise an exponent to another power or to another exponent, you are multiplying the exponents. So let's look at some of these other ones. Which of these do we want to see do, go over, have questions about using this rule? On the same page. Be shy. On the same page.
Oh, yeah, I was on the same.
12. 12. So something like 12, we have to remember that the 2 and the a to the third are two separate things, which means 2 has its own exponent, just like in this second set, 3 and a both have their own exponents. If you want to rewrite it so that the numbers are bigger, you can do that. So when we multiply each exponent, you have to think about it like distributing, kind of, but you're not distributing it to the number, to the base, you're distributing it to the exponent, so you're multiplying 5 to 3 and 5 to 1. So I'm going to expand it and write it to show each thing, but as you get used to this, you won't have to keep doing this. So this would be 2 times 1, 2 to the 1 times 5, a to the 3 times 5. I have a negative base, but it's being raised to a odd power, so I don't need parentheses. You can put it if you want. Negative 3 to the 1 times 3, a to the 1 times 3, and b to the 2 times 3. You're taking the number, the power that is being raised to, and distributing it or multiplying it to all the exponents. So this would become 2 to the 5th, a to the 15th, negative 3 to the 3rd, a to the 3rd, b to the 6th. So then we have to figure out the two numbers and combine any like bases that we have. So 2 to the 5th is
1. 2. Why are you looking at me?
You just use your calculator.
Oh, I thought I was adding
32. I'm going to rearrange this and move the negative 3 to the 3rd also. What would that be? Negative 3 to the 3rd power. Yeah, 27, but negative. Right. And then our A's, I'm going to put those together. Since we are multiplying like bases, we're doing what with those two exponents? Combining them how?
Adding them together.
Adding them together.
Oh, right.
So this would become a to the 18th. Multiply these two, 32 and negative 27.
Negative 864.
So you want your answers as condensed, as simplified as possible. There shouldn't be any negative exponents. There shouldn't be any like bases that you haven't combined. If you have numbers with exponents, you should be simplifying them, figuring out what they are, multiplying if there are multiple. So all of this became negative 864, a to the 18th, b to the 6th. Questions on that one or other questions on this page?
Wait, how did we get 32?
2 to the 5th.
Oh, never mind.
Well, how do you get negative 27?
Negative 3 to the 3rd. I just rearranged these two. So if you put in your calculator negative 3 to the 3rd power, you'll get negative 27.
Wait, then where did a to the 15th come? Oh, next to it.
So we multiply this to get this, and then we switch these two. Other questions on this page? Go on to the next page. So after this one, we will have 5 rules. Your negative exponent rule, your zero exponent rule, your multiplying like basis rule, your raising exponents to another power rule, and then when we divide exponents. Anyone want to take a guess as to what we're going to do with our exponents here?
Divide them.
We're dividing the like bases, but we're going to subtract. So I'm going to expand it just to show you that it works, and then we'll use the rule. So if I did expand this, I'd have a to the 6, a times a
You have
to
to
the
write
6 times. We're going to expand it just once. And then I can get rid of all of the A's that are similar. So these A's would cancel, these A's would cancel, leaving 4.
Okay, so that.
If I subtracted, I'd also get a to the 4th. So your rule is when dividing like bases, you subtract the exponents. So these 5 rules you have to know, memorize, be able to apply them in order to do and simplify all of these exponents. Wow. Looking at this page, which of these do we want to see, do, go over, have questions about?
Number 15.
Okay. So when you have negative exponents, you have a couple choices. You could change them first and then deal with multiplying, adding, subtracting, or you can deal with the multiplying, adding, subtracting first, and then if you have negative exponents at the end, deal with that. So you have choices. Right now, if I'm dealing with just the subtraction piece, the dividing piece, I have common bases for x, for y, for z. I could subtract all my exponents first. I'm just going to rewrite it just so you see what exactly is happening because we're subtracting no matter what. Remember that if you don't see exponents, it has an exponent of 1. So this will be x to the 2 minus 1, y to the negative 1 minus 4, z to the 4 minus a negative 3. We're subtracting no matter what. So this would give us x to the 1st, y to the negative 5th, z to the 7th. And then of these, the y still has a negative, so that has to come down. So in your numerator, x and z to the 7th stay. In your denominator, y to the 5th. If you had switched the y and the z at the beginning and still added or subtracted, you would still get the same thing. It just depends on which you prefer. Do you have questions about that one before we do 18? When you are simplifying this, you need to be thinking order of operations, parentheses, exponents, multiplying, dividing, adding, and subtracting. So if you have something inside the parentheses that can be simplified, do that first. However, if you don't do that first and do the exponent and then simplify, it should still work. So I'm going to show both. So I have like bases of m. We're dividing, so we're going to do what with the exponents? Subtract. So I have 5 minus 2 would give us 3. All of this is still being raised to the negative 4th. You could do one of two things here. Because it's being raised to a negative exponent, you could take this entire thing as the base, flip it, keep it in parentheses and raise it to a positive 4, and then deal with that. Or multiply the negative 4 to everything and then flip everything. So order you choose when you are doing that on your own. So for this, I'll just distribute, but if you wanted to flip it and then distribute, that also works. So the 2 has an exponent of 1, so this would become 2 to the negative 4 for multiplying, m to the negative 12. I'm going to flip both of these. And then what is 2 to the 4th? 16. 1 over 16 m to the 12th would be our final answer. If I did that the opposite way, so really quickly, we did that in reverse. Let's say I multiplied the negative 4 to all of my exponents first. You don't have to write this down, you can if you want. We have 2 to the negative 4th, m to the negative 20th. You have to do this to everything, so then m to the negative 8th. Combine or subtract your m's, your like bases. So it'd be negative 20 minus a negative 8, or really plus 8. And you see that we've gotten the same thing. And then we flip them. We actually don't need these parentheses anymore. I don't know why I thought. And the answer would be the same. So that order doesn't matter. You just have to be consistent. Questions about that? I'm going to give you some time to practice after we read through some of these rules. So go to the next page. You should see something that looks like this. So these are some, if you get stuck, these are things you could do to simplify. If you have a number outside of the parentheses, a power, exponent being raised to another power, distribute that number or multiply. If you have like bases that you want to move together, you can move them, get them together so that you know you're adding, subtracting, whatever. That should have said multiply. If the like bases are next to each other and you're multiplying, add the exponents. If they're on top of each other, they're dividing, subtract the exponents. Move negative exponents wherever they need to go. If it's in the numerator, move it to the denominator and vice versa. Simplify coefficients, so like 2 to the 5th, negative 3 to the 3rd. Simplify those down as much as possible. Get those actual numbers. Right? So on this next page, I want you to try as many of these as you can until about 8:10, and then we'll come back, we'll talk about any we want to see you go over, and then we'll be done for today. So I'll be walking around. If you have any questions, you guys can work together, but I want you to try as many of these as you can from this page. So were there any questions you wanted to see you go over, had questions about? Corinne, go back to your seat, please. Any others? If you didn't get to this, it's fine. I'll do it as I do it. Alright, so for number 7, just in case you can't read that, it says 2x to the negative 4th, y to the 3rd, z to the 5th, times 5x to the negative 4th, y to the 2nd. So everything is being multiplied. So you would add your like bases and actually multiply your numbers. So 2 and 5 equals 10. If you're adding your like bases, we have negative 4 and negative 4. So that would be negative 4 plus a negative 4 or negative 8. We have like bases of y's, 3 and 2 to the 5th. And then we have a random c that doesn't have a like base. So then of this, what would get changed is just the x. That would get brought down. Everything else would stay in the numerator. Questions on that one? Other questions we wanted to see you go over, questions about? I would advise you, this is not homework, but I would suggest, highly advise that you continue working through these problems bring any problems that you have questions about tomorrow / after school today / after school tomorrow to get help with them if you're not understanding. Because if we're going to briefly start with any questions again tomorrow on this and then move on to more complex ones tomorrow. Hold on to this packet, don't lose it. You guys can put your calculators